Scientists have been trying to create human stem cells. One Korean scientist claimed success in 2005, but this was a lie in one of the most notorious cases of scientific fraud in the last 10 years. The same team behind this latest breakthrough managed to clone monkeys with this technique back in 2007, a significant step. Embryonic stem cell research has repeatedly raised ethical concerns.
What it does is it literally opens the door to in vitro fertilization labs using these principles to make clones for people that might want to have a clone.
The technique used in Oregon is called somatic cell nuclear transfer. What the team in Oregon has done is take an adult skin cell and inserted it into a human egg stripped of its existing DNA. The unfertilized eggs are stimulated by electric pulses, and that starts them dividing. Scientists say the results from Oregon are hugely significant, a major step forward in the field and in the fight against some terrible diseases.
Remember Dolly the sheep? Back in 1996, she became the world's first cloned mammal. Dolly died at a comparatively young age, having suffered from osteoarthritis. Her death raised concerns that cloned animals may age more quickly or make them less healthy than normal offspring. But new research published in Nature Communications says that cloned sheep using the same method as that which created Dolly show no obvious detrimental long-term health effects.
The technique isn't new, the results are. Microscopic genetic material was taken from an adult cell. It was then inserted into an egg whose own DNA had been stripped out. This creates human embryonic stem cells, which are capable of becoming any of the more than 200 types of cells that make up a person.
Researchers studied 13 cloned sheep, including 4 created from the same genetic material as Dolly. The team ran metabolic tests and blood pressure measurements to analyze their well-being.
Pick up the leg and we'll flex and extend the joints and make sure they have a normal range of motion in them.
The sheep also had their joints x-rayed. The results were compared to normal sheep, though these controls were younger. Despite that limitation, the researchers say the study strongly suggests the very act of cloning doesn't perturb the aging process.
There was no evidence to suggest that these animals were aging abnormally or prematurely. They were aging in a perfect, healthy manner.
Experts not involved in the study says that conclusion may be premature. To really assess aging, they say, tests that measure vision, hearing, balance, and memory are necessary. The current work didn't do that. The cloned sheep are still alive and healthy, with no signs of metabolic diseases and normal blood pressure. Only one is showing signs of moderate osteoarthritis. Despite these findings, cloning can still be worrisome.
Cloning is still an inefficient process, but still quite a large number of embryos that are transferred fail to implant. And those that do implant, there's higher than normal incidence of failure during pregnancy. But for those animals that get through this period, what this study shows is that they can live for a long period of time and be perfectly healthy.
That's important because those cells could be used to treat devastating conditions such as multiple sclerosis, spinal cord injuries, heart disease, or even Parkinson's.
This laboratory in China has succeeded where other researchers have failed. Scientists at the Institute of Neuroscience in Shanghai created the first cloned monkeys using a technique called somatic cell nuclear transfer. The cloning process began with a monkey egg and a monkey fetus cell. The genetically modified process in the laboratory then develops into an embryo, which was then implanted in a monkey. Eventually, the babies were born. What's novel about this process is the nuclei were transferred from fetal cells rather than adult ones. That's different from the world's first cloned animal, Dolly the sheep, which was created from only adult cells. China is the first to successfully clone primates using this method. However, scientists are criticized for pushing ethical boundaries. The Chinese process took 127 eggs to produce 2 monkeys. Animal rights activists oppose medical research on monkeys. Given the progress in cloning primates, will people be next?
like any new technology, once it's appeared, there's always possibility of misuse.
For now, the police in central Russia continue to collect evidence following a gruesome discovery earlier this week of almost 250 fetuses dumped in a forest. They are thought to have been used in scientific research by a woman who worked at a local medical university before being fired last year. But as RT's Sean Thomas found out, some experts think the fetuses could even be the product of cloning.
Right now, the investigation is focused on two parts. First, how did these 4 plastic containers containing 248 fetuses end up in the woods about 70 kilometers north of Yekaterinburg? Why and where did these fetuses come from? The possible explanation is legal scientific research. We do know that all of the fetuses that are in question here were terminated between 22 and 26 weeks. This is well past the 12-week mark, which is considered legal abortion in Russia, and after 22 weeks, women can only have an abortion only for medical necessary reasons. So is this an illegal abortion operation, or is this scientific research? No one really knows. They're trying to get to the bottom of that. We talked to one medical doctor. This is what they had to say about the subject.
This looks like some sort of thriller where organs were removed from fetuses to extract essences that theoretically can be used to rejuvenate people. There was a criminal case in Ukraine a while ago when women were deceived into terminating pregnancies quite late to extract tissue for rejuvenation purposes.
There is one woman who is in charge of some scientific research in the area. She was terminated in 2011. Police are looking to see if she had taken some of the material she was working with her when she left, and if this could possibly be that material. Now, there are some other disturbing theories saying that illegal scientific research could be behind this find as well. In fact, this is what one medical expert says on the subject.
It may sound a bit fantastical, but these fetuses could have been the product of cloning, despite its universal ban. And that's why they were thrown out like that, since these were not future human beings, but half human, half artificial creatures.
Meet Millie, officially the world's smallest dog. Her folks from Puerto Rico can't live without her. Now they hope they won't have to. You love her?
So much. Yes. She's a really, really special girl.
So special, they are paying $100,000 to clone her. We've flown to South Korea, where NBC News has been granted exclusive access to what amounts to a cloning factory. The doctor behind the operation rarely gives interviews, but he's cloned nearly 1,000 dogs.
884.
Oh. And today, Dr. Woo Sak-wan is implanting a Labrador with embryos from Millie.
That's the moment. That's right.
In 2005, Dr. Hwan was at the center of a scandal for falsifying human stem cell research.
There's eye cream here.
Since then, he has rebuilt his business, even expanding into cosmetics.
Do you think people deserve a second chance?
Hopefully.
He's begun cloning cows to produce high-quality steaks at a lower cost.
Okay.
Simple as that?
Yeah.
This is to get better steaks?
Yes.
All of these?
Yeah.
Are all cloned?
Yeah.
And from these mammals to an even larger extinct one. In this lab, Dr. Hwan's team is trying to extract DNA from the remains of a prehistoric mammoth. Whether successfully, they wouldn't tell us. But around the world, in Russia, I meet scientist Alexei Tikhonov.
It's all mammoth bones here.
All mammoths. He searches for mammoths frozen in ice and time. Professor Tikhonov is collaborating with the Koreans, trying to bring the long-extinct species back to life. Mammoths lived during the last ice age, only existing today in movies.
A whole baby mammoth you could clone from an animal like this.
If you have such preservation, real hair, and hair, by the way, is one of the best sources of DNA.
The plan is to use Asian elephants as surrogate mothers. It wouldn't be easy and may never happen. But
you'd like to see thousands of these roaming Russia again?
Yes, of course.
You must be mad.
No.
So, could cloning one day be applied to humans? We travel to Scotland, the birthplace of cloning.
It was here, near Edinburgh, 20 years ago that scientists first cloned a mammal. Her name was Dolly the sheep.
Dolly's creator says since then, human cell cloning has helped the study of diseases like Parkinson's, but cloning humans would simply be unfair.
Clone of a major baseball player, you'd expect that child to be a baseball player. He might not want. He might want to play soccer.
And the scientist who's made cloning his business?
Do you hope one day to be able to do this kind of work with human genetics?
Absolutely not.
You don't?
Human cloning, scientists say, would be extremely difficult. It is also illegal in many countries. But as for man's best friend, the technology devoted to reuniting pet owners with a beloved companion is changing their world right now.
How are you, everybody?
There has been a big scientific breakthrough that may bring the world one step closer to cloning humans. Here's Jim Axelrod.
These two female monkeys, Wawa and Zhang Zhang, are 7 and 8 weeks old and represent the next big step in cloning. 22 years ago, Dolly the sheep became the first mammal cloned from an adult, followed by nearly 24 more mammals, including dogs, cows, and pigs. Scientists at the Chinese Academy of Sciences in Shanghai have now cloned a primate for the very first time. Dieter Egli is a researcher at Columbia University.
I'm really astonished that they were able to make this happen.
What makes it so astonishing?
More than 20 years we knew that you could clone sheep and horses and cats, but despite several attempts, everybody failed when cloning monkeys.
The Chinese scientists say the goal is to create genetically identical monkeys to use in medical research, especially in the battle against Alzheimer's and Parkinson's.
An average of 22 people die in America every day while waiting for organ transplants. A group of researchers affiliated with Harvard University and also a private company hope to eventually change that statistic by using organs from cloned pig cells. Their method uses the powerful technology called CRISPR to edit the DNA of the animals. It removes potentially harmful viruses from the pig's organs. Scientists then clone those edited cells, put them in an egg, and implant that egg into a sow. This enables them to ultimately breed pigs with virus-free organs. Our Dr. David Agus is in Los Angeles. Good morning. We just went through the process here. What does this ultimately mean, though, for humans?
It's absolutely wild. I mean, literally considered science fiction several years ago. Now, with this enzyme CRISPR that can, with surgical precision, change one of the letters of the DNA code, they can eliminate several dozen viruses that have always been in the pig genome. And in studies done before, if you took pig cells and human cells and put them together, the viruses would go to the human cells. And so now they've been eliminated or inactivated. So all of a sudden it opens the door for the potential of pigs. You know, pigs' organs are about the same size as human organs. So they're actually perfect for transplantations.
Doctors regularly use pig valves in heart surgeries on humans. So I'm just wondering, how is this different?
Well, Jeff, pig valves are put in formaldehyde first, and so they're not live pig tissue, but they're put in formaldehyde and they're fixed, and then they're put in. And again, that shape of the pig valve is very similar to ours, so they're used for valve transplantation. But these are live cells, functioning organs, kidneys, livers, hearts. It really is going to be dramatic how it could affect many human lives.
Dr. Agus, the ability to edit DNA seems to be gaining rapidly as the science advances, but there are some legal and ethical concerns here. What are they, and are they valid?
Well, you know, Vlad, last week we did the story of, changing a human embryo. When you change an embryo, the DNA is passed generation to generation. Here, it's just in the organ. But we need some group in charge, not just in the U.S., but internationally, to start to draw boundaries. We're talking about some dramatic advances and literally happening week by week, but they can keep going. And so the challenge is to do it right. The challenge is someone not to change an embryo to make them taller, stronger, faster. The challenge is to do it to benefit human health in a positive way on a global sense.
These macaque monkeys are more than just a couple of cute faces. They are the first primates cloned using the same method that made Dolly the sheep.
Scientists have been able to clone various species, but they've made no headway really in cloning a monkey. And primates, like humans, seem to have egg cells that are a lot more fragile. So maybe that's one of the reasons why it's so difficult.
The findings were published in this week's journal, Cell. Scientists say it's an important breakthrough, considering their close relations to humans.
We've been waiting for this work a long time, almost 20 years after Dolly the sheep. And I can tell you, sometimes the public is not aware of how much non-human primate research have helped human health. And so this would open the door to new therapies.
Dolly the sheep was the first mammal to be cloned with DNA taken from an adult. It was announced in 1997. About 24 mammal species have since been cloned through a similar process. These two were born genetically identical within the last 8 months at the Chinese Academy of Sciences in Shanghai. The cloning process begins with a monkey egg and a fetal monkey cell that has been cultured in a lab dish. Researchers remove the nucleus, which contains the DNA, from the egg. The other cell is slipped into the egg, so it replaces the egg's nucleus with its own. The egg then divides and grows into an early embryo, which is implanted in a monkey and grows to term. It took 127 eggs, of which 79 were implanted as embryos, to produce 2 babies.
So I think that they did an incredible amount of work. There's still things that we can improve for sure. And this is going to be one of those seminal papers that we're going to be referring back to for many years to come.
Scientist Jose Cibelli at Michigan State University says if the process becomes efficient enough in monkeys, the public could face a big ethical dilemma whether to adapt it for use in humans. Currently, mainstream scientists and ethicists generally oppose trying to make human babies from cloning, citing safety and other concerns.
This, in a sense, will start the conversation again about whether we want to use cloning as a way of reproduction in the future or not.
So far, the baby monkeys are growing normally. The group is expecting to clone more macaque over the coming months. The Chinese researchers say cloned monkeys would be useful for medical research.
Today, science has given us the ability to manufacture clones, exact genetic copies of mammals.
The woolly mammoth is a cultural favorite, a long extinct animal that can still capture the imagination. We commonly accept the woolly mammoth became extinct at the end of the last ice age 10,000 years ago due to a combination of climate change and human hunters. But suddenly, this loss might not be permanent. There are a handful of projects across the globe working to bring extinct animals back from the dead. They call it de-extinction.
What I would emphasize in de-extinction is de-extinction of DNA, not so much of species.
Leading one of those projects is Dr. George Church, a professor of genetics at Harvard University. He's a genius.
This is the tRNA that I solved helped solve as a teenager.
To create new mammoths, Dr. Church started with a close relative. Then he made some key changes to its genome.
Our lab and others have developed a whole variety of genome engineering tools. One of them is CRISPR. The way that CRISPR works is that you calculate in the computer a particular set of 20 ACs, Gs, and Ts in a row, and then the CRISPR protein cuts, and then that cut alters the gene. In this case, we've already edited 15 genes, and we're well on our way to doing another 30-some genes that have been selected to specifically help the modern Asian elephant survive in more environments than it currently have, particularly cold environments.
De-extinction has plenty of detractors. They feel it provides an all-too-convenient backup plan to habitat destruction that humanity has caused. And more practically, where do we put resurrected animals that no longer have a natural habitat? Dr. Church has a place in mind for that part.
The tundra, which is one of the largest gigantic ecosystem throughout the top of the world, is melting. The soil is very thick, full of carbon and melting. And if that carbon escapes, it could be equivalent to twice the carbon in the atmosphere and twice the carbon in all the forests. So what could elephants do? By allowing cold-resistant elephants or mammoths to repopulate the tundra, they will punch down the snow in the wintertime, allowing cold air to come in, and in the summertime they'll knock down trees, which are very absorbent, and release the grasses from their from the dead grass so they grow well and reflect light. When you simulate this with real ecosystem in Siberia, the temperature drop is 20 degrees, which is a really big deal in terms of delaying or, you know, the release of carbon by melting.
Proponents of de-extinction believe that bringing back the mammoth would represent a turning point for what we can do with genomes, and the positive effect our work with genomes can have on the world around us. And of course, it would give us the chance to say hello to an old friend.
The woolly mammoth only died out 3,000 years ago. There were woolly mammoths when there were people building pyramids. And so woolly mammoth DNA we actually have.
Where do we get it?
From the Arctic. It's coming up out of the ice. These perfectly preserved woolly mammoths, their tusks are worth $250,000 a tusk.
Wait a minute. It was warmer back then, even though there were no
The
SUVs?
Ice Age was ending. The Ice Age
Well,
was
I
ending.
think you got your facts wrong here.
Right, right.
So they were actually in a warmer place and then were frozen? So this has happened before this war?
There have been multiple changes in the environment over
that.
time. It's true.
From
it's
what?
true.
Without cars?
From woolly mammoth cars. You saw the Flintstones.
Yeah,
they were driving cars.
I did. A big side of ribs.
Right. It knocks the car over.
Yeah.
So the woolly mammoths are coming up out of the ice. Scientists are taking the material, they sequence the DNA, and they're placing it into Asian elephant embryos. So an Asian elephant gives birth to a woolly mammoth. That's the Woolly Mammoth Project going on at Harvard. It's Dr. George Church, who is basically the Einstein of our times.
There's reasons to do this, Ben, right?
Yes.
It's not just for fun.
No, it's
why do
really
we want a woolly
it's
mammoth?
to save the world. And so the permafrost is this giant ticking time bomb. It's this frozen permafrost that covers the ring of the world, and it contains within it more carbon dioxide than if we burned all the forests on Earth 3 times. And it turns out...
It's methane, too, right?
Methane, horrible stuff.
Which is worse than...
And it turns out that if you can repopulate the tundra with large herbivores like woolly mammoths, these Russian scientists have proven this, they knock down trees, they push up the snow, they actually make the permafrost colder. It can make it as much as 15 degrees colder. So the goal is to release a herd of woolly mammoths across the Siberian tundra.
All right,
I mean, it
now-
sounds insane.
This actually sounds kind of interesting.
No, now I'm back. I think the premise of Jurassic Park is probably more likely than,
Well,
than any of this.
you know, an
This
amusement
is-
park would be more fun, but this is a
it's
real
more
good
likely,
reason to
probably
do it. Yeah.
Yeah, in someone's view. Okay, well, that's a different subject. We'll get on. So how many genes do you need?
Well, the Harvard lab is trying to go for 23 genes.
And that would do it.
The shaggy red hair that you think of a woolly mammoth, the big tusks, the ability to live in the cold, because elephants don't really live in the cold, and things like that. Right now, in existence in Boston, there are 3 prehistoric woolly mammoth genes alive in Asian elephant cells. So it's kind of a wild fact that, you know, a few miles from where I live, there is living woolly mammoth right now. So we're very close.
The
and
genes are being expressed.
yes, they're
in elephants,
living
but
in organoids and
genes
like that.
don't really live, but
Right.
I see what you're saying.
Yes,
Anyway,
the cells are alive. Yeah.
Okay.
Yeah, it depends. I mean, with definition of life.
Right.
But the point
Well, you
is
can
that
actually- you can
we
make a
can do
bacteria
this.
now,
The
so-
science is all there.
Yeah.
So it's just a matter of placing it into the Asian embryo and having an Asian elephant give birth to it.
You are looking at the moment when the love of Danielle Tarantola's life, in a sense, returned from the dead.
How cute. Hi. Do you remember me?
This is the culmination of a more than 20-year odyssey.
Wait, I have to pick him up.
The result of an encounter with the growing, high-tech, and highly controversial industry of dog cloning. Danielle's journey started when she was 18 and she bought a dog named Trouble from a pet store.
The trouble wall.
On her pillows, on her bedspread, and dressing him up in elaborate costume.
He cannot have been happy when you put this on.
Of course he was. He looked very, very handsome.
You loved this dog.
Loved him. Loved him to death.
And when Trouble died when he was nearly 18,
He was basically my son. So it was terrible. It was heartbreaking.
that is when she took her love for her dog to a level some people might find truly bizarre. She reached out to an animal cloning company in South Korea, the only place in the world where you can get your dog cloned. She provided them with a DNA sample of Trouble that she had banked when he was alive. The cost, $100,000, although Danielle, who had recently lost her job on Wall Street, convinced the company to give her half off because her journey was being chronicled by TLC for a show that airs next week.
50 grand. Did no part of you think, That's just too much money.
No, I was willing to do it for 100. I got a deal.
A few months ago, Danielle got a phone call from the scientists in South Korea. The surrogate mother of Trouble's clone was successfully impregnated.
Just this morning in Korea, we've been able to confirm the pregnancy of Trouble.
Oh, I'm so excited.
Weeks later, the surrogate went into labor in the middle of the night as Danielle watched nervously via Skype.
Oh, how cute is he? He's so cute. Bye, Trouble. Mommy will see you soon.
Not all clients are so lucky. Quite often, as in the case of this man's dog, the clones do not survive.
Come on, puppy. Come on, my true love. Come on, my sweetheart. Wake up, wake up.
And that is just part of the reason that the dog cloning business is now so fiercely controversial. John Westendick wrote the book Dog Inc. about the dog cloning industry, which he says is based in South Korea because that country has much lower ethical standards for the treatment of dogs than we do here in America.
If you're a scientist in South Korea and you're looking to clone dogs, it's a much better environment.
Yeah.
This is a country where they farm dogs for the dinner table.
Right, and so you can just, rent them from the farmers for use in the laboratory, and then hopefully, if everything goes okay, return them to the farmer where everything's not going to go okay.
That's right. In Korea, some people eat dogs, and Westendick says some of the dogs who are used in the cloning process as egg donors or as surrogate moms are later sent back to dog farms where they are killed and eaten.
Does that give you any pause?
I did ask them a lot of questions about the surrogate mom and what happens to her and, was she treated okay?
They told her and us that the surrogate used in Danielle's case, as well as all of the surrogates they use, are sent to a nice farm to live out their days. But John Westendick is not so sure.
It sort of sounds like, what you tell your kids when the dog dies. He's gone off to this lovely little farm.
He also worries it puts mankind on a slippery slope toward human cloning.
Once we've cloned man's best friend, how far behind might man be? It seems to, be tilting closer to that.
That, however, is not an issue that appears to concern Danielle.
Oh, you're giving me kisses.
Just a few weeks ago, the clone arrived at Danielle's home in New York City.
I couldn't believe it. It's amazing. Everything is the same. Everything. Even his personality is the same. What Trouble used to do, he does.
So his name is Double Trouble.
Double Trouble, yeah. First one's Trouble, second one's Double.
She is convinced Double Trouble is very similar to the original Trouble, but the truth is, there is no guarantee.
You're not really getting your dog coming back to life. You're getting a genetic duplicate or a twin. What's special about your dog, that's the part that I don't think can be cloned.
What about the complaint that this is all a ripoff, that you're not getting the same dog, and you're being charged an enormous amount of money?
Right. Well, what I did, listen, what I did is definitely not for everybody to do. It was what I wanted, so it was, what I did.
Despite the criticism and the controversy, Danielle is undeterred. In the process of making Double Trouble, the South Koreans also produced a second clone. He will arrive at Danielle's house in weeks. She's thinking about naming him Triple Trouble.
Since the birth of Dolly the sheep in 1996, scientists have managed to clone about 20 species, including cats, goats, and sheep. Now they've taken a step towards something a lot more controversial, cloning a human. What the scientists have done is created a human embryonic clone. They start by taking a human egg, take out the nucleus, and then they take a skin cell from a patient, take the skin cell and put it into this denucleated egg. The skin cell that's been transferred is sort of the software, and the egg acts like a hardware, and the hardware essentially boots up the software and creates an embryonic clone. From the embryonic clone, the scientists can derive other stem cells and go on to make heart tissue or nerve tissue or any other tissue that goes on to make a person. The goal of this research has nothing to do really with cloning. Cloning is just a tool. The idea is to create fresh tissue in a lab. If someone has a heart attack and you have scarring inside, you could use fresh tissue made in the lab to treat that scarring. If someone has a nerve ailment like Alzheimer's disease, you could transplant lab-made tissue into the person and hopefully treat that kind of malady. One of the biggest challenges in creating a human clone is that very few scientists are going to be willing to try this kind of experiment. The reason is it's incredibly controversial. It's banned in many, if not most countries, and it would provoke a huge outcry. However, there's always an outlier or two among the science fraternity who in some country, in some underground lab, may be willing to try and clone a human.
Life must end in death.